In this section, we'll go over graphs and charts that depict data values. In question 1, the graph shows the value of a car depreciates each year. This graph helps to find the trade-in value of a car for each of the 5 years. The percent given in the graph are based on the selling price of a new car. Let's look at part A. What is the approximate trade-in value of a car that is $13,000 after 1 year? Let's look at the chart, and we can see here that at 1 year, the value of the car is only 70%. It's 70% of the original value. So to calculate 70% of $13,000, here's what we need to do. We need to multiply $13,000 by 0.70. That's 70% as a decimal. 13,000 times 0.70, and that's going to give us our solution. And this gives me a value of $9,100. So after only 1 year, the car is only worth $9,100, and we started with an original value of $13,000. In part B, how much has a $15,000 car depreciated after 3 years? Again, we'll refer to the chart and we'll look at 3 years. After 3 years, it appears that we're going to have a value that is only 40% of the original value. We'll convert 40% to a decimal. That's equivalent to 0.40. And again, all we have to do is take our original value, which is $15,000, and multiply by 0.40. And this gives me a value of $6,000. So in 3 years, our car is only worth $6,000. In part C, what is the approximate trade-in value of a car that is worth $10,000 after 2 years? Let's look at the chart for after 2 years. In the 2-year mark, it appears that this is at 55%. Each of the increments is 5%, and so I am pretty sure this is at 55% of the original value. Let's go to part C. We'll take $10,000 and multiply it by 0.55. Again, you have to convert the percent into a decimal. This gives us a value of $5,500. And that completes question 1. Question 2. The graph to the right shows the number of snow shovels sold in winter months at a store in 2010 and 2011. Please pause the video and give question 2 a try. In part A, which month did the store sell the most snow shovels in 2011? So according to our chart, it appears that's the month of February. The 2011 has a peak in February. In part B, during which month did the store sell the fewest snow shovels in 2010? And again, most of these are self-explanatory. We can see that the lowest value on the chart for the year 2010 is in March. So for part B, the answer is in March. Part C, based on snow shovel sales, which year, 2010 or 2011, seems to have had the most snow in the store's locale, and why? If I look at the chart, notice that in 2011 we have 4 out of 5 months having higher snow shovel sales. That tells me that in 2011 we had more snow because 4 out of the 5 months had higher sales. Question 3. Coach Washington kept track of the jumping records for the basketball team for a 10-year period. Draw a line graph for the data. Notice we have a table here, and you could click this double rectangle here so that you can upload the values into Excel. Now you could also do the problem by drawing it by hand. You can put the year here on the horizontal axis and the number of inches on the vertical axis and draw a line graph that way. But we should use technology because it's convenient for us. Now what if you don't have Excel? All students at SUS can get Excel for free. When you log into your Office 365 account or your COS email, you can install Office here by selecting this option, and it will include Excel, or you can click here to get to the Excel program. So again, you can get the Excel program for free because you're a COS student. So let's get started with the problem. Once you click that double rectangle box here, it should open into Excel. And here is the data in a table written in Excel. You can also type this by hand in a vertical orientation or a horizontal orientation. That's up to you. To do this problem, we're going to highlight the data values, and then we're going to select Insert, and I want either recommended charts, or you can pick any of these graphs here in the middle. It's up to you. You can pick a line graph, you can pick columns. I like to select recommended charts to see what options they have. And we have many different options. I'm going to select the first one, the line graph, because it's in recommended charts, and select OK. And here's our line graph. So this depicts a decreasing number of inches as the years progress. So the years are in the horizontal axis and the number of inches are in the vertical axis. If you want, you can also change things about the graph. You can select this chart styles option and you can change it any way you like. There's many options to select from. Just play with the options. You can also select the data again, but instead of selecting recommended charts, you can go to charts and select either scatter plot, a smooth scatter plot, or a line scatter plot. It's up to you how you want to depict your data values. Question 4. Consider an arithmetic sequence with first term of 5 and difference 2. Part A, plot the sequence as a scatter plot. Part B, sketch a trend line. Part C, find an equation for the trend line you sketched in Part B. For question 4, we can also do it in Excel. Well, we have the first term is a 5, so that's a 5. The next number has a difference of 2 from it, so the next number must be 2 more than that, so 7. And the next number must be a 9, and the next number must be an 11, and so on. Let's try this problem on Excel. In Excel, we're going to type in the position and the terms. Now for the position, we have the first number, the second number, third number, fourth number, fifth number, sixth number, and so on. We can put as many as we want, but we only need a couple. Now for the terms, we know that the first term is a 5, and the next one's going to be 2 more than that, so that's 7, 9, 11, 13, 15, 17. The common difference is 2 between each of these numbers, so this is an arithmetic sequence. Now in part A, we want to do a scatter plot. Highlight the data values, and you can select Insert, and select Charts, and we want a scatter plot. So let's select the first option here for scatter, and we have our scatter plot. Now on the right of this chart, there should be a plus sign. There should be a plus sign to the right, and you might not be able to see it on my screen, but I do see a plus sign. Select that plus sign, and then you can select trend line. Once you select trend line, this is the trend line, the best fit line for this graph. Here's a better view of the options here. Again, there's this plus sign that you should select, and you should be able to select the trend line. Now in the last part of the question, we want to find the equation for the trend line. To find the equation of the line, we need to select some ordered pairs. I'll select the first one here, 1, 5, and the second one here is 2, 7. We could find the equation of a line by first finding the slope. M is equal to y2 minus y1 over x2 minus x1. We can label this as x1, y1, x2, y2. Let's plug in the values. This is 7 minus 5 over 2 minus 1. In the numerator we have 2, in the denominator we have 1, so the slope is 2. So the slope is 2. We have the slope. How do you find an equation of a line? We need to use y minus y1 equals m times x minus x1. We will plug in the values for y1. y1 is 5 and the slope is 2. X minus x1. x1 is a 1. And now we can simplify this. Distribute the 2. Y minus 5 equals 2x minus 2. We can add 5 to both sides. And finally, we get the equation of the line is y equals 2x plus 3. This is our equation, y equals 2x plus 3. In question 5, in the following scatter plots, find an equation of the trend line pictured. Now we have several options, A, B, C, and D. The best way to look at this trend line is to determine if it's positive or negative. It rises as I go to the right. It rises as I go to the right, so this has a positive slope. So option B is not possible and option D is not possible. Now the next thing I want to figure out is the Y-intercept. The Y-intercept is located here, and the Y-intercept is below the x-axis, so the Y-intercept must be negative. And that means option A is not possible, so our solution is C. We have a slope that is positive and the y-intercept is negative. There's only one possibility for this trend line. Let's look at part B. In part B, we have a situation where the graph rises as we go to the right, so this has a positive slope. So option A, option B is not possible. Now we need to figure out what the y-intercept is. The y-intercept is very close to 3/4. The y-intercept is 0, 3/4. So the only option here that I see is option D. We have y equals 1/2 x plus 3/4 is the equation of this trend line. So eliminate the possible choices by looking at the slope and then looking at the y-intercept. Question 6. A trend line has the equation y equals 3.8x minus 0.01. What y value would you expect to obtain when x is the following? Let's try part A. For part A, we want to have an x value that is 1. We have y equals 3.8, and what we're going to do is we're going to replace this x with a 1. So let's simplify this. 3.8 times 1, that's just 3.8 minus 0.01. We can simplify this with a calculator, and y is equal to 3.79. Please pause the video and try part B, C, and D on your own. Let's try it together. For part B, it's pretty easy. We're just going to replace that x with a 0 this time. And this simplifies really quickly. Y is equal to negative 0.01. For part C, we'll replace x with a 15 this time. 3.8 times 15 gives me 57 minus 0.01. This simplifies to 56.99. And for part D, we're just repeating the process. We're replacing the x with a 20.1. 3.8 times 20.1, that yields 76.38, and we'll have to subtract 0.01. And this finally simplifies to 76.37. So these are fairly easy questions, but definitely try these on your own. Question 7. What type of association exists for the data? Is there an identifiable trend? If so, sketch it. Let's look at our charts. We have two charts to look at. Chart A. You can see that there is a trend. We can draw a rough sketch of a line, and there is an association. There is a trend. It is a positive association because as I go to the right, the graph rises. So there is a trend line, and that's a positive association. There's a positive relationship. Let's look at part B. In part B, it seems random. I can't really draw a trend line. It doesn't appear to be horizontal, rising, or falling, so I don't see a trend line. There's no trend line. There's no identifiable trend. There's no positive, and there's no negative association. It just seems random. Question 8. A trend line has the equation y equals 13x plus 0.06. What type of association would you expect to have? If we were to graph this trend line, we would have a y-intercept of 0.6 and a slope of 13/1. So it would look something like this. And since it rises as we go to the right, there has to be a positive association because the slope is positive. So I can clearly see there's a positive association with this trend line.